Hey everybody, welcome back to AP Physics C, Unit 8. This is topic 8.2. This is conservation of charge in the process of charging. So conservation of charge is very important because essentially, how much charge you put into a system is what you get out, no matter how much, gets spread amongst all the objects in the system. So the net charge or charge distribution of a system can change in response to the presence of or changes in the net charge or charge distribution of other systems. So there's a lot going on in that statement. So you can think of net charge is going to be is due to friction or contact between systems. So friction would be like if I need to charge a rod, right? I'm going to rub it with like rabbit fur or felt, thus stripping electrons off and passing it off to the rod, or from the rod to whatever I'm rubbing it with. The other thing is once you have it charged, then you can put it next to insulate or conducting spheres, and that's what's going to happen. Is that the charge will then kind of conserve and move around and follow our rules for charges. So what we're doing is we're actually inducing a charge, and what happens is when a charge is induced, separation will occur because the electrostatic force between the systems alter the charge distribution or charges, resulting in the polarization of one or both systems. So induced charge separation can only occur in neutral systems. So if I zoom in real quick, we look at this little diagram. So basically I have two spheres, conducting spheres, neutral right now because you don't see any charge on them. Then I bring a positively charged rod towards sphere A, thus inducing a negative charge on A because they're going to separate. So negatives are going to go towards the positive due to our electrostatic force. And the positives are going to move away. And where do they move? Well, they're going to move on to B. Okay, so they're going to try to get away from the positive rod and over on B by itself. And then when we hold A and we start to separate the two spheres, we're getting this separation more, okay? And then ultimately we pull the rod away. Thus now we have an induced charge of negative on A and a positive on B. So this is kind of like, rubbing the balloon on the head. I don't have that, issue. I can't do that experiment. But, that's what we're trying to do, induce charges. Now, any change to a system's net charge is due to a transfer charge between the system and its surroundings. And what happens is it's the transfer of electrons, right? Not necessarily the transfer of protons. In fact, you can't transfer protons. It's the transfer of electrons. So if you have, again, we talked about it in the last video, right? If I have an excess of electrons, that's a negative charge object. And if I have a deficit, right, that is a positively charged object. And then really cool application is grounding. So grounding involves electrically connecting a charged object to a much larger and approximately neutral object. For example, the Earth. And in fact, this picture is actually from my house. If you go to your house, you're going to see, this stake here in the ground. Well, that's the grounding, which means anything that comes off of the house is going to pass right into that neutral object, right through that wire into that stake, and thus going into that much larger object known as the Earth. So this is an area where the application in physics is very important, right? Because we don't want charge sitting on our houses. We're going to let it run through the ground and get into that Earth. So it soaks it up, right? Because whatever charge is coming off of our house will be completely taken up by the Earth. All right, so let's look at an example again. So we have two identical metal spheres standing on insulating stands. Sphere 1 has a charge of negative 1.02 times 10 to the negative 16. Sphere 2 has a deficit of electrons of 841. So it's written a little bit weird, but sphere 2 has a positive charge because it tells us that it has a deficit, right? The two spheres are brought together so that they touch each other. They are then separated again so they are no longer touching. What charge does each sphere have after they've touched? And then now we consider the new charge on sphere 2. Does this correspond to a deficit or an excess of electrons? And then how many electrons? Okay, so what we need to do is really find how much charge exists in the system. So I'm going to do 841 times 1.6 times 10 to the negative 19th, right? Because that's the amount of charge on an electron. So sphere 2 is going to have a charge of 1.35 times 10 to the negative 16th. Let me just double check that because I kind of have just some scribbles on my paper here. So 841 times 1.6 exponent negative 19. So 1.35 times 10 to the negative 16. Okay, coulombs. Now what I'm going to do is I'm going to add that to sphere 1's charge to figure out what is the net charge on the system. Right, so I'm going to add to the negative. And then, so we got answer plus negative 1.02 e negative 16. And so this tells me 3.3 times 10 to the negative 17th coulombs in the system between sphere 1 and sphere 2. But what happens is the charge gets distributed evenly. So if I want to find the charge on each sphere, I just simply divide that number by 2. Right, and so this is going to be a plus, so plus 3.3 times 10 to the negative 17th coulombs divided by 2, which is going to be 1.6, right, or 1. I rounded, so 1.6 times 10 to the negative 17th coulombs, right, and so it's going to be a plus. So that is the charge on each. Right, so it'd be a 1.65 if we want to really get technical, right? So that is the answer to our first question. What charge does each sphere have after they touched? And now we're going to consider the new charge on sphere 2. Does this correspond to a deficit or an excess of electrons? Well, positive tells us deficit, right? So it's lost electrons, even more, because now, so actually not more, it's actually added a little bit more because the charge is a little bit more, okay? And then how many electrons are in that deficit? So we're going to take that 1.65 number and we're going to divide it by, essentially we do a conversion factor, right? 1 electron is 1.6 times 10 to the negative 19th coulombs, right? And so I take our answer, 1.65 exponent negative 19 divided by 1.6 exponent, negative 17th divided by 1.6 exponent negative 19. So we get a number of 103.125, but remember, charge is quantized, so we got to round down, right? We can't have partial electrons, okay? So charge, or essentially what happens is each sphere has 103 electrons on it. All right, so that's going to conclude this video for the conservation of charge. In the next video, we're going to focus on electric fields.